We've covered 3-1 and 3-2. We have 3-3, 4, and 5 left. We will do 3-3 today. There's a chance we might start 3-4. It depends because 3-3 is short. You should be working through the homework. The test was originally going to be Friday. I don't know that that's going to be possible because we're only in 3-3. It looks like it might be a Monday test. But remember how we're going to do the test now, where we're not doing the practice one. We're going in and taking the test one time through as your review, and then you're coming back in the next day and taking it again, but with no notes. Okay? So it's basically another homework assignment. It just is more high stakes, right?
Is it for us, like, have help and do similar questions and stuff like that?
That is the downfall of taking the test. It won't offer you an example. It won't offer help me solve this. Honestly, though, I feel like y'all did better on the chapter 1 I feel like y'all were less stressed out when you took it one time through without those features, and then you knew immediately what you needed to study. I feel like when you took the practice test for chapter 2, you really didn't get a clear picture of what you needed to study because you may have been clicking, view an example, help me solve this or something. You know what I mean? So no, it will not offer that while you're doing it. However, you can go into the practice test and find a question that matches it, and then you could use that feature. I want you to think of it as another homework assignment that you're going to do one time through to see what you actually don't know, and then you're going to study what you don't know and come in, and then that's when you're going to take it again. Okay? Yes? Yeah, what I'll do is I'll set it to where it'll reveal results and allow you to go in and look at it, because that's the whole point, right? So yes, it will do that. You do have to get it through your grades, though. Remember, there's 2 places. There's assignments and then there's grades. If you're going to review it, you got to go to your grades and then hit review. Any other questions? No, that looks like it's going to be Friday. And then over the weekend, you just need to practice what you got wrong. And then Monday, we will be starting the test by 8:15. So any questions that y'all have from it, you need to ask Friday, or come to my Flex Friday, ask, or you need to message me and remind over the weekend. And that way on Monday, we're ready to start. Okay? All right, so we're looking at 3-3. You need a graphing calculator, or a calculator just in general for this one. We have 10 slides. 9 of them are the lesson, and then 1 of them is me saying to you, here's what it's going to look like on a homework question. I don't want you to get confused, okay? We're looking at the graphs of quadratics. So this should feel really comfortable from what you learned in Algebra 2. We're looking at the vertex, the axis of symmetry, if it has a max or a min, graphing them, and then, of course, word problems that involve the max or the min. Going to the first slide, I want you to highlight the vertex form that's right here. Get a highlighter and highlight this. That is vertex form of a quadratic. And the reason it's called vertex form is because you can see the vertex. I love how they name things in math, because if you don't know what you're doing, the way they name things helps you with it, right? The vertex is going to be the coordinate point which means an x and a y value, that are in the positions of h and k, I am putting an asterisk in front of h because look at the sign in front of h. What's the sign? It's negative. That means there's a sign change. So I'm going to put an asterisk right there too. And then I'm going to write up here that the asterisk stands for sign change. It's very similar to when we did equations of circles. And remember, you had to change the sign of both of them because it had negatives. Okay, here with quadratics, you just have to change the sign of the number in the position of h. Now, let me connect it back to what we've already done, back to the last chapter, transformations. H represents the x-coordinate, right? And the x-coordinate is your right and left movement, correct? And that's located inside the parentheses for the quadratic. Go back to the last chapter. Remember I said anything inside brackets, parentheses, whatever, the H is a right and left movement, and it's counterintuitive to what you see, which is exactly why there's a sign change here. So if I saw x minus 4, then the H value would actually be positive 4. Okay? Come right here. Consider all of these here. This is the mother function. That's the mother function. Y equals x squared. That is the mother function for quadratics. Now, to go from the mother function to this one right here, it's going to be a what transformation? It's a vertical stretch by a factor of 2. It's in the very, very front, which means it's your vertical, right? Anything in the bars is your horizontal. This is not in bars. This is in the very front. This is a vertical stretch. This is the rubber band thing that I told you. It takes a lot of energy to stretch it, right? Okay, from that one to this one, you got the vertical stretch by 2, then it's in parentheses, so it's going left 3. This right here would mean left 3. Okay, then that is vertical stretch of 2, left 3, then it's going down 5. If that's still a little fuzzy from the last chapter, you need to make sure you understand those by now, because it's going to really help, okay? So make sure you understand your transformations. Now, I don't think we have any horizontal stretches right now because they don't apply in the word problem. So we've got the nice, clean vertical stretch, horizontal shift, or vertical shift, okay? All right, go to the next slide. You already know this. This is me putting everything you should already know about a quadratic on one slide. You should know that if the leading coefficient is greater than 0, which means it's positive, it's going to open where? It's going to open up, right? So let me hide this and put lead coefficient is positive, then you have this. It's going to open up. If the lead coefficient is negative, it's going to open what? It's going to open down. I'll just have to write it because it's going to look weird. If the lead coefficient is negative, it's going to open down. All right. look over here at all of this. You might want to highlight again that HK is the vertex. Remember, there is a sign change on H. We already addressed if it's opening up or down, depends on the leading coefficient sign. The vertex, where's the vertex always located in a parabola? Where? At the max or the min, right? It's the very top or it's the very bottom, and it's right in the center. It is the center of the quadratic. This right here is the vertex. This right here is the vertex. The vertex of a quadratic is always the max or the min. Always. Every time. Every day. All day. Every single time. The words max and min should be self-explanatory. A max means it's topping off. That means it's opening down. A min means it's bottoming out. That means it's opening up. The new part here that you may recall from Algebra 2, I don't know, is the axis of symmetry. Let's go back to the word symmetry. Symmetry describes when you have a shape that you, perfect example would just be a good old-fashioned rectangle. Imagine this was perfect right here, you know. So if you have a rectangle and you fold it hot dog ways, there's symmetry, right? If you have a rectangle and you fold it hamburger style, there's a form of symmetry. Would you agree? Okay. So with quadratics, there is a symmetry to it every time, and that's because it's always opening down or up, and it can be folded right down the middle. I'm going to change colors. Right down the middle is the line of symmetry for a quadratic. Well, what did we already say is always in the middle? The vertex is always the middle point every time. So the axis of symmetry then has to pass through the vertex every time because it's in the middle. It splits it every time. I love when I'm able to say every single time. There's never an example where they don't line up. The axis of symmetry passes right through the vertex, which means that the equation, oh my word, that was too much. Hold on. The equation of the line for the axis of symmetry comes from the vertex. It's simply x equals whatever the x coordinate is in the vertex. This is the equation of the line for the axis of symmetry. Don't overthink this. You're going to have to memorize it, but it's intuitive. Intuitive means if you'll just think about what you're looking at, it'll lead you to the answer. It's going to pass through the vertex, right? And what type line is the line of symmetry on every quadratic? What direction does it run? It runs vertical. What is that acronym that Miss Holcombe told you? Hoi-vux. And since it's always vertical, that means we're going to always look at the vux part of that acronym, which tells me any vertical line can be written in the equation by x equals wherever it's crossing the x-axis. You don't have to look at the x-axis. You can just look at the x value of the vertex, which is another thing. I'm going to connect it. You ready? Let's see. I'm going to write it over here. I see it in my head. I want to make sure I don't. I'm going to come right here. Make a note. The vertex x value is the equation of the axis of symmetry. See where I'm going with this? What did I underline every time? the vertex x value is the equation of the axis of symmetry. They're all connected. So, for example, no, I can't, they don't have numbers, but let's say this was like 1, -5. What's the equation of the axis of symmetry? It'd be x equals 1. Let's say this is -1, 3. What's the equation of the axis of symmetry? It'd be x equals -1. It's the x equals whatever the x value is of the vertex. Now the min and max values. These, if you think about it, what direction does min and max imply? Min and max implies what direction? Of motion, like, or movement, up and down. So what axis runs up and down? The y axis runs up and down. Max and min implies up or down, how high or how low. So when you're talking about the max or the min, they want the y value. And it's going to be the y value of the vertex. This is the beautiful thing. If you know the vertex of a quadratic, you know a lot of stuff just by finding the vertex. You don't even have to graph it. If you just know where the vertex is, bam, you know that it has the axis of symmetry at x equals whatever the x value is. You know that there is either a max or a min at the y value of the vertex. You would have to look at the leading coefficient to see which way it's opening to decide if it's a max or a min. Okay? All right, go to this slide. Let's practice. Recall the formula for vertex form. The formula is f of x equals a, parentheses, x minus h squared plus k. That's the formula. All right, let's look at one example, and then you're going to do the other example on your own. Here's this example here. This is in place of A. This is in place of H. This is in place of K. What do I need to remember about H? There's going to be a sign change. Okay. What is the vertex of this quadratic? It's the numbers in place of H and K with a sign change on H. So it would be 1/4, comma, -2. Once you know the vertex, now you can answer the axis of symmetry question. What is the axis of symmetry? It's the x equals 1/4 line. That is a line. You're not saying, that's not a point. You're saying it's the equation of the line x equals 1/4, which is a vertical line. Probably feels weird to write that. Probably feels like you're writing in like a stagnant number, but it's a line, okay? Now you have to ask yourself, does it have a max or a min? Look back at the original equation. Look at A. A tells you it's opening what direction? It's opening up, which means it's opening up, so it's bottoming out, has a minimum, which means there is no maximum, has a minimum. What is the minimum? -2. It is the y value of the vertex. So y equals, let's see, how do they, my math lab wants you to write it, look, remember, they want you to say minimum is, now list the y value, -2 at what x value? Remember, that's how my math lab makes you write it in, okay? So let's make a note right here that these two are the y value of the vertex. Now, y'all do the second one. I need to never do that. It's so not comfortable.
Took your whole day.
Yes, I had to wear it yesterday and I had to wear it today. I washed it last night. It was annoying. Goodness, crap. I washed it. I'm about to turn it inside out. So that you can't see much either. Because every time I look down, it's go get it? You might need more time. Good for me to go over it? Which way is it opening? It's opening down. Okay, what's the vertex? Vertex is -5, 7. So the axis of symmetry is x equals -5. If it's opening down, it has a max, and the max is 7 at, good. I just love that. Now, where's the leveled up coming in? Okay. The leveled up comes in on the next slide. Look at this one right here. Find the vertex, the axis of symmetry, and the maximum. So we're doing the same thing, right? What do you notice though? It's in standard form, it's not in vertex form. Okay, so that's the leveled up aspect. Ideally, you need to complete the square. I'm gonna show you two ways to do this. One way, you need to know how to do. You need to know it. The other way is going to get you through it. You see the difference between the two of what I'm saying? So the first way is going to be the way you're supposed to go, and you need to know how I did it. You should be able to reproduce it should I ask you. But the second way is going to be what gets you there faster, works every time. And honestly, if you understand the long way, there's no problem in taking a shortcut. Shortcuts are designed for when you know the long way and you can appreciate the long way takes too much time, so you have a shortcut that works, right? I don't like shortcuts to be looked at as less work, like less intuitive, less work. I think if you know both methods, then there's nothing wrong with taking a shortcut. So here's what we need to do. Let's take some notes. There's going to be a lot of writing on this side. The problem here is that this is in standard form. That's the problem. So if you're reading this question and you're trying to understand what to do, you should see that equation and think to yourself, okay, crap, I can't answer the question because it's in standard form. Then make a note. We need vertex form. So I'm going to draw a vertical line right there. Actually, probably right there. And now I'm going to come over here. when you need a quadratic to be in a binomial squared format, you have to do what's called completing the square. Okay, so this goes back to 3.1 or 3.2. I don't remember which section. We're going to copy the equation. So we've got f of x equals x squared plus 10x. If you recall from completing the square, we got the variables on one side and the number on the right. We really don't want to put 23 on the other side because it's not 0, it's f of x. So what we're going to do is we're going to draw a line to say, okay, I'm fixing to add something here. I'm going to copy the plus 23. What's the rule in math? You can do whatever you want as long as you... Okay, well what if I only want to stay on one side? So if I add 4, what should I do right behind it to keep it balanced? Subtract 4. Have you ever seen that? Go to something simple. Think of just a basic equation. I can do whatever I want as long as I do it to both sides, right? Y'all already know that. Okay, I forget one side. Focus on just the other side. If I want to tweak anything on one side of an equation, whatever I do, I need to come right behind it and undo it. Because then I'm technically not changing it, right? Does that make sense? I'm going to show you. So if I'm fixing to add something right here, I need to come right behind it and subtract it. Because then I've negated what I tweaked, and that way I've not changed the value of it. It would be the same thing as if you had added to both sides, but then you just said subtract that one right over here. We're trying to manipulate the equation in order to be able to write it as a binomial squared. I can't write it as a binomial squared in that form because it's not perfect. So I'm going to create it, I'm going to manipulate it to become perfect. Then I can write it as a binomial squared, and then bam, it's in vertex form. Okay? Alright, so the shortcut, this is where we're doing the shortcut for completing the square, from this crap to here. If you remember, copy the variable, you're going to draw parentheses, copy the variable, copy the sign, b, which is in front of x to the first power, b over 2 squared. That's this crap right here that I just filled in. Bring this down. Minus b over 2 squared. I know y'all can do 10 divided by 2 in your head, but it really helps with the shortcut if you will just write, plus b over 2 squared. Just write it, and then go to the next line and then clean it up. Because then at least you're looking at it and you're saying to yourself, did I do it right? Copy the variable, copy the sign, b over 2 squared. Come right behind it because you're on the same side. Now you're going to subtract it, b over 2 squared. Now let's clean it up. 10 over 2 is actually just 5 squared plus 23. This is minus 5 squared. I don't even have to put plus 23. I'm going to change colors. What is this, y'all? Go to your calculator. 23 minus 25. Negative 2. Does everybody agree? Go to your calculator. I'm going to leave it in green because that came from me just cleaning that part up. Now I'm going to bring the f of x down. Now look. This is now vertex form. which means I can see, what did it ask? It said, what is the vertex? The vertex is, you just did this on the last slide, -5, -2. What is the axis of symmetry? X equals -5. Is it opening up or down? Where do you look to determine that? Look at A. A is +1, so it's opening up. It's opening up, which means it has a min. The minimum number is the y value of the vertex. So it's a min of -2 at x equals -5. Do y'all see how we did that? Now, you might think to yourself, well, that was only, if you look at it, y'all, that was only 3 lines. Right? And honestly, this was the answer. I begged you not to try and do 10/2 in your head. So it was only 3 lines. So this is a very intuitive way to manipulate it. I encourage you to try it, get used to it, because it will make you more comfortable with manipulating equations. Now let me show you the alternative way, okay? I'm going to teach you a formula that you probably remember from, I don't remember what class it's taught in originally. It might be Algebra 1 or Algebra 2. All right, question. If the question in my math lab is just asking for this, right? Just that. Then you can go this alternative way. All of this came from knowing the what? Back up. All of this came from knowing just the vertex, right? I can answer all of these questions. Look where I'm pointing. I can answer all of this if I simply know the vertex. Would you agree? If my math lab does not ask for the vertex form, then I would say go the way that I'm fixing to show you. Now, if they ask for the actual vertex form, then you will have to go this way, okay? Let me take that off. All right, now, here we go. So what's the alternative way? The alternative way is just find the vertex. How do you find the vertex? The x-coordinate is -b/2a. And plug x in to get y. So you find the x-coordinate using the formula -b/2a, then you plug that in, and then bam, there's your y value. And that's your vertex, okay? So, for instance, let me show you. Up here, A is 1, right? B is 10. Notice C is nowhere in here. Okay, so we'll put, for example, x equals -b/2 times 1. -10 divided by 2 is -5. Now plug -5 into the entire function. Find f of -5. Plug the whole thing in. -5. So you'll go to your calculator. You'll type -5 in parentheses squared plus 10 times -5 plus 23. Confirm that you get -2. make sure you're using parentheses right. Did you get it? Do I get -2? So then the vertex is -5, -2. Honestly, you could write the vertex form by just plugging that in and copying your A value. Look at the A right here, it was 1. Plug this in. Remember when you plug it in, there's a sign change on the X value, the H. So if you plugged it in, you could generate the vertex form if my math lab was asking for that equation. Take stock of both of them, okay? I don't want you to just, go through the motions. I want you to understand it. This is called completing the square. It's when you take something that is not perfect and you force it to be perfect so that you can see the vertex format. If you appreciate that vertex form only comes from knowing the vertex, this formula right here gets you the x coordinate, then you just plug it into the equation and there's the y coordinate. Okay?
How did you get -2?
Plug it in.
Yeah.
Go back to the original. Plug -5.
Go back to this.
Yeah. Go back to the original and plug it in. That's it. All right, let's practice. Let's go to the next one. And I want to make sure before I show you, I'm sore. Let me show you, let me check. I always like to do the homework before y'all do it, to know in advance. The 3-3 homework is 12 questions. The first 8 questions are what's the vertex, what's the axis of symmetry, what's the equation. Question 9 and 10, 11 and 12 are word problems. I don't see any like this example. Hold on 1 second. All right. Let's look at this one. Find the vertex, the axis of symmetry, and if it has a max or a min. Okay, so the goal is to be able to state the vertex, the axis of symmetry equation, and if it has a max or min, and where, right? Looking at the equation, is it in vertex form? No. You know it's not because it doesn't have parentheses squared. When you first look at it, it probably looks really confusing, right? Let's rewrite it. This means 1/2 x squared. Let's rewrite it. Now, would you want to complete the square here with a leading term of 1/2? No. You don't want to complete the square with that 1/2 in the front. And we don't want to have to go through undue stress, let's call it what it is, if it's not necessary. Go back to the shortcut that I showed you. Find the x coordinate using -b/2a. Find the x coordinate. All right, well, what is b in the original? It's -4. Now, when you plug that in, there's two ways to do this. You can write the negative here, then write B every time, which in this case would be -4. Or you could in your head say to yourself, okay, so it's going to become +4. It's up to you. Over 2 times A. Woo, that's ugly. Let's clean it up. What's a -4 become? +4. What is 2 times 1/2? 1, right? What's 4 divided by 1? 4. Oh, I'm almost there. Right? Did I say 2 divided by 1/2? I think I meant 2 times 1/2. How do you get the y value? Plug x in. Plug the one you just got in. So find, in this case it's g. G of 4. Go to your calculator. I would type what instead of 1/2? 0.5. It'd be a lot easier to type in your calculator, right? Sorry, Chase. Plug 4 in. What do you get? Did you get 0? Now you can answer the questions, right? So the vertex is 4, 0. The axis of symmetry is x equals 4. Go back to it and look at A. It's opening up, which means it's bottoming out. So it has a min of 0 at x equals 4. I just want y'all to know that that is so much easier than completing the square here. You were going to have to multiply by 2 on everything to get this to be a 1. And then it was, you had to keep the 2 until the very end, and you had to plug it back in. Like, So that little shortcut is going to save you the headache when the quadratics are ugly. Now let's go to the word problems.
Yay!
We got 3 slides left. One of them is me helping you with the homework. Guess what? This slide, I already showed it to you. This is where in your textbook they make you go the long way to appreciate the shortcut that's coming up, right? This is showing you, hey, did you know that the x-coordinate is just negative b over 2a, and the y-coordinate is just, hey, plug that back in. You already did this. Now, this is the fancy notation for it. Look at it to understand where it's coming from. This is in the x position. That's the formula I taught you. I put the negative on the top, though. I don't put it in front of the fraction. Doesn't matter. This is saying f of x, and x was this. You just plug the x value back into the function, and then you get the y value. Okay? Let's make some notes. X equals negative b over 2a. Then the second part is plug x in to get y. You've already done this. So right now, you practice number 4. It says, here's your function. It's in standard form. They want the vertex, state whether it's a max or a min. Lucas, here's a range question, which means yeah. All right. We're going back to being able to understand domain and range. Just right here, just on this.
We need to change the signs.
What do you mean?
Isn't that
The formula negative b over 2a? Is that the one you're looking at?
No, the actual function. The main function.
No, it just means A is -1, and it means it's opening down. That's important. You really don't even need C, do you? As far as like finding the X coordinate. To answer the range question, sketch the graph. Doesn't have to be perfect. The only number that matters is the vertex. Sketch the graph, and then you should be able to answer the range and the increasing and decreasing. Is everybody ready for me to answer A and B? A and B? Okay. Find the vertex. So X equals -b over 2a, negative, then b, then 2 times a. So -14 divided by -2 is +7. So then find f of 7. Plug it back in. Did you get 2? Okay, so the vertex, I've organized all my stuff over here. So the vertex is 7, 2, right? Okay, based on A being -1, it's opening where? Down, which means it's topping off, so it has a max of 2 at X equals 7. Okay, C is asking for the range. I'm going to go ahead and write it. And then D is asking for increasing and decreasing. Okay. How are we going to answer C and D? You're going to go to your paper and you're just going to sketch the graph. When I say sketch the graph, I mean think of where it is. So it's right 7 up 2, opening down. So right 7 up 2 puts us in quadrant 1. So right 7 up 2, opening down. Right? This is 7, 2. Everybody with me? Now, some of you are still messing up your domain range, increasing, decreasing. Here's another chance. Here's a chance to understand it again. First of all, when you sketch your picture, label your, we're just talking about range, right? Range is which axis? The y-axis. So I'm going to label my y-axis. This is negative infinity. This is positive. Increasing and decreasing, you look at the x-axis, This is negative infinity. This is positive infinity. Range means tell me all of the y values used in this graph. If I was to sit down and list every single point on that curve, what would the list of y values look like? That's what range means. Okay, you cannot sit here and list every one of them because how many points are on that curve? Infinite. So you have to write an interval. That's why it's called interval notation. You're saying, hey, it's every number from here to here. Always read range from least to greatest. And, well, everything's from least to greatest. Negative to positive. So if you look at it, it's opening down, which means it's covering all of these numbers, right? Do you agree? It's covering every number on the y-axis up until 2. Does it have a y value of 3 on this graph? No. Can y'all see that? Okay, so what is the range? It's running from negative infinity, this is why this is helpful, and it's stopping at 2. And it's definitely touching 2, which means it needs to be a bracket. So the range is negative infinity up to 2. Now, increasing and decreasing is the same concept, but this is where you think of a runner is on the graph. Like imagine a runner. So the runners always start on the left, always. Least to greatest, negatives to positives. The runner would be doing what first? Increasing until they got to the vertex, then they would be decreasing. So I'm going to use yellow for increasing. No, how about I'll use blue. I'm going to use blue for increasing and red for decreasing. So all of these numbers, all of these points on this curve going down to the bottom, as it's going down, it's also going out, right? Don't be confined in just what you see here. Imagine this is going down and out. So it's eventually getting all the way, right, to the negative infinity. So from negative infinity up until the number 7, he's running up. Then at 7, he switches and starts running down. You see that? So your interval of increasing is negative infinity up to 7. Your decreasing is 7 to infinity. Now here's where you got to let common sense kick in. If I put a bracket on 7 at both of these, then that says he's increasing at 7, then he's decreasing at 7. Is that possible? No. That's why increasing and decreasing is always parentheses every time. Every time. Because you really don't know what's happening at those critical values. So increasing from negative infinity to 7, decreasing from 7 to infinity. We're going to skip around for a second because the next word problem doesn't really tap into this, but the one after that does. So go to example 6. Go to this one. Height of a rocket. A model rocket is launched with an initial velocity of 100 feet per second from the top of a hill that's 20 feet high. Its height in feet, t seconds after it's been launched, is given by this function. Determine the time at which the rocket reaches its max height and find the max height. Remember with word problems, read it multiple times, draw a picture, ask yourself, what has Miss Holcombe been teaching? Because whatever she's been teaching is going to get used right here. What have we just been dealing with, y'all? Starts with a V. the vertex of a quadratic, right? They've just shoved it into a word problem. And they're all the same. It's a rocket that gets launched. It's a ball that gets thrown. It's someone at the top of a cliff that drops something. It's a shooting star. I'm trying to think of everything. We're going to draw a picture. He is at the top of a hill that's 20 feet high. This really doesn't even matter. He's standing up here on the top of the hill, right? He launches a what? A little rocket. Where's the rocket going to go at first? Up. Then it's going to do what? Down. And what is the only part of a quadratic that we've been interested in? The vertex. Everything you need to know comes from the vertex. What is my equation? Oh, it's this crap right here. Right? T stands for how many? You have to read it. T stood for, it's right here. It really helps, especially with understanding word problems, to write what the letters stand for. Reading the problem, it says the height is in feet and T represents seconds. This says its height, the rocket's height in feet, after it's been launched, is given by this function, which means they're telling you, here's your equation to get the height of the rocket at t seconds, which means that the s of t part represents the height. They're telling you right there what the y value represents. It's just not a y, it's an s of t function notation. And remember, it says determine the time, which means find what? Find, in this case, t, right? They're saying determine the time at which the rocket reaches its max height. What part of a quadratic is always the max? The vertex. And they only want the time, which is the what coordinate? X coordinate. You just set it right here. Like, look, t is your input, which means t is your x here. So they're telling me that t is my x here, and what's the formula I showed you for the x coordinate? Negative b over 2a. Right, b is 100, so put negative 100 over 2 times negative 16. You would go to your calculator and divide that. Negative 100, did I lose you? Okay. Negative 100 divided by negative 32, and what do you get? 3.125, and that was seconds, right? It says determine the time at which it reaches its max height. We just did that. Then it says and find the max height. Well, which value is that? That's the y value. You just found the x value. So now take that and plug it in. So S of 3.125. Now we need to interpret it. Make sure you understand this. So the max height is 100 76.25 feet at how many seconds? 3.125 seconds. After it's been launched, right? Can y'all indulge me for 2 minutes to do example 5? I'll show you. I will tell you, if you want to try it, you've already learned the concept. You are going to use the formula A equals length times width. We will do it first thing tomorrow. Okay, this one, a landscaper has enough stone to enclose a rectangular koi pond next to an existing garden wall. That's important. They're telling you that one side of the rectangle is a wall, which means you don't have to worry about it. So, you have your picture right here. You could come over here and redraw it and think to yourself, okay, I got a wall. I'm going to enclose a rectangular area for the pond. And it says with 24 feet of stone wall. So that means you have 24 feet to work with. So our total amount of stone to work with is 24 feet. And then it says, if the garden wall forms one side, what's the maximum area? And then what are the dimensions? Okay, so we're looking for the dimensions of a rectangle, which means we need to know the length and the width. And then we're looking for the maximum area. Well, once you know the length and the width, you multiply them and that gives you your maximum area. So you've got to remember the formula for the area of a rectangle is length times width. Now, we can't find the area here with 2 variables. We need to come to our picture and we need to write expressions. Now you'll see they've already done it. You can see here it says W, and then here it says 24 minus 2W. Let's understand where the 24 minus 2W comes from. If I've got 2 widths to enclose, and I have 24 feet total to work with, then for this last remaining side, I would take the 24 that I have left, subtract off the 2 widths that I've already covered.
Alright. Recording something?
Hold on 1 second.
That's fine.
So the remaining side here is going to be 24 minus 2W, and now we can write our area function. We have a expression for the length, 24 minus 2W. Then we've got the width is W. Since we've written it now in one variable, we can simplify this expression and get our quadratic. You can leave it like this, or you can multiply it out. This is multiplying. And then now, if you really want to understand the quadratic, put it in standard form. So your leading term needs to be the one with the highest degree. Watch your signs when you cup game shuffle these around. Now we can see our equation of our quadratics, negative 2W squared plus 24W. Now the question asks for maximum area and then what are the dimensions? Okay, there's 2 ways to do this. You could go to your calculator and do second calc and then find the max. Or the more intuitive way would be to use the shortcut that we learned where you find the x coordinate in this case, it would be the W coordinate. So the width is negative B over 2A. Pull that formula. Now, either one of these works. You can go calculator or you can go shortcut. Negative 24 over 2A. So negative 24 divided by negative 4 is 6. And we're in feet. To get the length, two ways to do this. You can come over here and look at your dimensions. So if you've got a width of 6, plugging it in right here, 24 minus 12 would give you a length of 12. So our answer, spell it right, dimensions, we've got 6 feet by 12 feet, which came from the vertex of the quadratic. So then that would produce an area. If you multiply 6 times 12, that's going to produce an area of 72 square feet.